get the file, looks like we will have to use the direction of the address. And look how it looks like. So you got some classic output of the regression tables. Let me try to increase this. We got the dependent variables definition, which is the income. And then we got the two models estimated. So we got the first model, which is the investment only in linear terms. And then we got the second model, which is in linear and quadratic forms. So this is 0. Let me double check if that's actually 0. Yeah, it's 0 since this thing over here, the power a times 7 minus 7, it's just a really low number. So yeah, it's 0. We got the classic description of the regression outputs, which indicates the number of observations, which indicates the number of linear adjustment of the goodness of fit of the model, which represents in this case an 88.9% of explanation. We got some estimates of the mean of the residual standard errors and the F statistics test. So a Stargazer command is pretty useful because you can also export it using LaTeX. Now let's get to the file. Yeah, all right. So we're going to use then the address of this, which I already got here. So we're going to copy this, and then we will go to R, and then we will just replace this over here. And we specify now the output, which is going to be rec1 htm. And now we'll run the command. And oh, it actually created both of them. Huh, quite interesting. So the previews also work it. Let me just do another additional test before we open this up. We're going to delete this one, and we're going to run the previews. So I will just type Control-Z, yeah, like this, and then Control-Enter. And then it's not displayed here in the files, but it's displayed here. So yeah, it actually works out with the work file directory. So if I double click this thing over here, it should open up a web page indicating this output. But sometimes it is not useful to have it in HTML. So you can use another stuff, which is just opening Word. So you get to open with, and then you just select Word, and here it is. And here we got it. You can now paste this in your research as a table, and everything will be fixed. So this is the power of Stargazer, pretty useful. The only drawback that I've encountered using Stargazer, it's in the simultaneous equation modeling, which is not able to put the outputs. You will have to use another package, which is called TextRec. And TextRec is, in comparison, almost as powerful as Stargazer. Is there any question up to this point? I would like to finish this part of the session by discussing a bit about the classical linear assumption. This is an applied lab, but it's important that we get to see some of this. So before we finish this first part of the session, let's discuss about the linear assumptions. So quick difference, classical linear assumptions can be towards the assumptions which we perform the linear regression models. So several authors may appoint the same, that they are going to be the same assumptions that any linear model should satisfy. That is the classical against the contemporaneous perception of linear models. So Woolrich, for example, appoints several assumptions for either the cross-section or the time series analysis, which are derived from the least squares estimators. And some authors do differentiate against these assumptions that a cross-section should satisfy against that the time series should satisfy. And the classic example is the autocorrelation phenomenon. For example, you don't need to worry about autocorrelation in cross-sectional data because this is just cross-sections, right? So it makes a bit of sense to discriminate the assumptions regarding the type of the data. Now, the classical linear assumptions involve that if we are starting from any linear model at the very first thing is that the expected value of the residual should be equal to 0. The second is that the variance of the residuals should be a constant behavior around the observation. So that is for each prediction of the residuals, that is for each row or for each observation, such behavior of the expected value of the square residuals should be a constant, should be some constant deviation. There should be no correlation between the errors, and this is a representation of the time series autocorrelation. So whenever the observations are different, imply that maybe there is an existence of a relationship between the errors. Whenever the covariance is equal to 0. If the covariance is not equal to 0, that means we got some dependent error structure.